Welcome to episode 5 of this Hoku tutorial series. In the last episode, we made an RGB or color image and learned how to save images in Hoku. There are two types of processing in Hoku: deterministic and statistical processing. In today's episode, we're going to start with deterministic processing. Deterministic processing is processing which has predictable results. We actually already did some of this in the last episode in the form of rotate, but it also includes things like blur, crop, invert, saturation, scale, sharpen. All of these are deterministic processes. You probably already have some experience with them doing image editing on your phone, so I'm not going to be going into detail on how to use them. The parameters they take aren't that complicated. It's nothing you couldn't figure out after doing some very simple experimentation, but there's a good chance you'll know how they work right off the bat. But besides these, there are other deterministic modules in Hoku which are more useful for actually improving the legibility of text. I'm going to go over 3 in this episode and image math in the next episode. The 3 deterministic modules we're going to talk about today are Normalize, Power, and blur divide. In order to use these, all you need is an input and an output. So in this case, I'm going to use a read image and a show. The first module we'll start with is normalize, and we'll put that in between our input and our output so that we're seeing the normalized image. Select one of your multispectral bands in the read image module. Probably don't choose an infrared because you won't have much text in those images. Choose an ultraviolet or visible image. I'll just choose this one. And that is the image we're going to normalize. Now in the normalize module, we need to give it some parameters. The only required one here is neighborhood. So this is what we'll look at. This is asking for the size of a window or ROI, which it's going to use to do the normalize calculation. It's easier to show than it is to explain. So I'm just going to tell you right now that most of the time for normalizing images, you'll be using a neighborhood around 300. You can give it a specific width and height by just putting one number in there. You get a square with the width and height of 300. I encourage you to experiment with different numbers in here so you can get a sense of how different values affect the output image. But like I said, 300 is typical for improving the legibility of most text. So we can close our normalize module and you can see we have a completed job. Our input is one of our multispectral bands. We're going to normalize the image and we're going to show the image. Now, what I'm actually going to do before we run this job is include a new show before the normalize. This way we can get an image before normalization and an image after normalization so we can see the difference. I'm also going to check the linked box in each show so that the image windows are automatically linked and they'll be aligned when we're flipping between them. Now we can go ahead and execute and we'll see what it does. So here we have our normalized image. I'll go ahead and rename this to normalized so you know that this is the normalized image. And then this is our image before normalization. This is just our raw multispectral band. Switching between the two, you can see there is quite a difference. All of the text has gotten much darker, but there has been quite a significant increase in noise. What Normalize is actually doing is it's taking a window of the specified size that you gave it, and it is looking at the pixel in the very center of this window. It's then adjusting the contrast of that pixel based on the statistics in the rest of the window. So it goes one by one across every pixel over the entire image, adjusting the contrast based on the statistics in the region. This gives a sort of localized adjustment, which has the effect that you're seeing here. So like I already said, this darkens the ink, but at the cost of increased noise. This is a great tool to use when you have very faint text in an image with relatively low noise. The undertext beneath the overtext here will always be difficult until we get into math and statistical processing. So you can see the overtext has gotten darker here, just like the undertext has, but because the undertext is underneath, it doesn't really improve this text that we're trying to read. This is also the first time we've had a read image as our input into a show module, and I'm just going to briefly speak about what you have down here in the bottom right. Because it's not a read stack, you don't have multiple bands to flip through, and you instead get these options to adjust the minimum and maximum values of your image. So I've been attempting to move these sliders on the other image, but it's actually been crashing the software. So I've had to pull up a new image here. Like I said, you're just adjusting the minimum and maximum values. So you can play around with these and see if they give you any interesting results. If you get something you like, you can copy the text string to your clipboard and then paste it into a pack module in the min-max field. So if we go ahead and paste that into there, you'll see we get an image that looks like the image we adjusted in this window. These were added in the latest version of Hoku, and I've been getting some errors trying to use them just now. So there might be some bugs if you try to slide these. They're not that important, just an additional feature in this show window for single band images. Going back to the original image we had, you also have 3 available options for adjusting the contrast by stretching the minimum and maximum values. These are available in pack, so you don't have to do them here, but just play around with these and see if they give you any improvements. And if they do, you can add it to your pack module and save an image that way. You also have the option to color map a single band image. If you click gray, you get jet and perula. These are 2 methods of adding color to a monochrome image. And again, just like the stretching methods, these are available in the pack module, which you can select here with color map and then the color table. That's everything in the show window for single band images, and now we can get back to our deterministic processes. So we looked at normalize. Like I said before, this will darken your ink, darken your text at the cost of increased noise. It's great when you have faded text on a relatively low noise image. It works best when there isn't any overtext because you often get these veils around the edges of high contrast elements, like the overtext here and the edges of the page. And this veil can sometimes make it more difficult to read the faded text, even though the normalize is making it darker. So just be aware of that. The next deterministic module we're going to talk about is blur divide. We can put it in between our show modules so we can see the before and after images. The blur divide module is already green, but if you click on it, we do have some optional parameters. I'm going to change the neighborhood to 300 like we had for the normalize. This is the value that I typically use, but like with normalize, I encourage you to experiment with different values here to see how it affects the results. We're not going to mess with the shape or number of blurs. Same thing with the value of neighborhood. Mess around with these and see which one works best for you. We can close up our job and execute it, and then I'll explain what the module is actually doing. The blur divide takes this image, blurs it, and then divides it from itself, and that gives the effect that you're seeing here. It has reduced the contrast of the bright and dark elements in your image. So we can see here the parchment is very bright and the fabric next to it is very dark, but in the blur divided image, you can see the 2 are about the same color. Blur divide does a good job of reducing noise, but because it equalizes the dark and bright elements of the image, that can sometimes reduce the contrast of the text on your parchment. You can see here it has brought the levels of the parchment closer to the levels of the ink, which has made it more difficult to read. I use blur divide a lot, and I highly recommend you trying it out if you have very noisy images. We'll now move on to the final deterministic method in this episode, which is power. Power is red, which means we need to give it additional parameters. If we click on power, we get a window where we have to select an operation. The operation you select in power is applied to all of the values in the image you want to edit by the value that you give it. So in this case, if we select power and give it a value of 3, it will raise the values of all of the pixels in our image to a power of 3. You can see it's not a major difference with a value of 3. If we put a larger value in here, like, 7, you'd see a much bigger difference. This is the difference between a power of 3 and a power of 7. By raising all of the values in your image to a power greater than 1, you are emphasizing high contrast elements. You can see it's made everything in our image darker. So if we look perhaps at this string of letters here, You can see it's much darker than it is in our original image, but because everything else has gotten darker, the contrast isn't great. For these images, power has really increased the noise as well, which doesn't help with the legibility. Logarithm, on the other hand, will do sort of the opposite. So there are no additional parameters for logarithm because you're just taking the logarithm of the values in your image. But you'll see here that it actually makes the darker elements, so the ink, brighter. It's not a huge difference, but it also reduces the noise in your image. We can see if we zoom in very closely, the difference a bit better. The image with the logarithm applied has a bit brighter ink, but less noise. Logarithm is another module that I use a lot, but not necessarily in the sense that I use it to directly recover text. I instead use it for pre-processing, which is when you process images before doing statistical processing. I'll show you this in a later episode, but just for now, it's good to know how logarithm works and that we'll be using it in the future. I recommend playing around with all of these operations in Power and giving different values to see how they affect your images. I recommend doing the same thing with Normalize and Blur Divide. These are modules that you'll probably be using a lot in the future, so it's good to get an understanding of how they work and how they impact results. So these are the 3 deterministic modules in Hoku that I consider the most useful for actually affecting the legibility and contrast of text. In the next episode, we'll continue with deterministic processing in the form of image math. This is when we can start not only improving the contrast of the text we're trying to recover, but also suppressing or removing the noise or elements we don't want to see.